All right, we're going to get started with our special right triangles. And the special right triangles that we have are 45, 45, 90, and 30, 60, 90 degrees. So the first one we're going to look at is the 45, 45, 90. And basically with the 45, 45, 90, these are the things you need to know about the legs and the hypotenuse that make up this triangle. So for this type of triangle, you know that both legs are congruent. Okay, and I'm going to zoom in. Both legs are congruent. And the length of the hypotenuse is the square root of 2 times the length of the leg. So, with this triangle, I'm gonna zoom in a little bit more. With this triangle, we know that the legs are congruent, so it's 45, 45, so this is X, and this is X, and so these are our congruency marks, okay? Now, for my hypotenuse, it's going to be the length of one of the leg multiplied by the square root of 2. So we're going to have this X, which is the length of the leg, times the square root of 2. So I'm just going to write down here so that you know that the hypotenuse is equal to X times the square root of 2. All right, so these are the components you need to remember about a 45, 45, 90 degree triangle. All right, so moving on to the 30, 60, 90 degree triangle. In this triangle, we know that the length of the hypotenuse is twice the length of the shorter leg. And the length of the longer leg is the square root of 3 times the length of the shorter leg. All right, so this triangle is a little bit more complicated in regards to, we have this 30, 60, 90 degree triangle. So the length of the hypotenuse, so this is my hypotenuse. I am going to write this in purple. I know it looks like the dark blue, but this is my hypotenuse. And we said that the hypotenuse is going to be twice whatever the short leg is, okay? So let's first write out what's my short leg. This is going to be my short leg here. And this is going to be, I'm trying to see what color I should use for the long leg. I guess I'll just stick to this blue here. And so this is my long leg. So I'm going to use X to represent my short leg. And so we know that the hypotenuse is going to be twice the length of the shorter leg. So my hypotenuse is going to be 2 times x. And my long leg is going to be square root of 3 times the length of the short leg. So here it's going to be x times the square root of 3. Okay, so some things you need to know, which I'm going to write down here. Sorry, there's not a whole lot of room. My hypotenuse equals is going to be 2 times the short leg. And the long leg is equal to the short leg times the square root of 3. Okay, so let us do some problems, and we're going to start with our first example, example 1. And we're going to need to remember some of these things that we learned about 45, 45, 90-degree triangle. So let me zoom out a little. I'm looking at our example. So example 1, what is the value of each variable? So we have a 45, 45, 90-degree triangle. So I'm just going to write that up here, 45, 45, 90. So we need to know some things here in regards to what a 45, 45, 90-degree triangle looks like. So when I talk about that, I know that my legs are going to be congruent. So my legs are going to be x. And so I need to find out what each variable is. I already know that this is equal to 9. So I'm going to say, hey, I know x is equal to 9. Now, my hypotenuse we learned is going to be equal to, is going to be x times the square root of 2. So showing that here, this is going to be x times the square root of 2. Well, if I know my x is equal to 9, I'm going to write x here, square root of 2 is equal to my h. And solving for, I'm just going to substitute in what my x is equal to. So h is going to be equal to my x, which is 9. And I'm going to multiply it by the square root of 2. Okay, let me move this over. There we go. All right. So we know what our variables are, and h is equal to this. All right. Okay, moving on to the second part of this example. We have another 45, 45, 90-degree triangle, and I'll just write that down here. Okay, so using the information that we know, that our legs are congruent and that our hypotenuse is x times the square root of 2. So I know that they gave me my leg. This is 2 times the square root of 2, and this is x. So this seems kind of backwards, but no worries. This piece, 2 times the square root of 2, I'm going to put in y, okay? This is going to be equal to my y because I wanted to have a variable, okay? And for this piece here, x, this is going to be, I'm going to use y again. This is going to be y times the square root of 2, okay? So I know that y, since I have it here, y is equal to 2 times the square root of 2. And my x is equal to y times the square root of 2. Well, I'm going to substitute in what I said y is equal to. So it's going to be this. So this is equal to 2 times the square root of 2 times the square root of 2. Well, 2 times the square root of 2, we're going to stick with this blue, sorry. So this is 2. The square root of 2 times the square root of 2, it looks like this. I have the square root of 2 I have them both under the square root underneath the house. Well, this is just going to be equal to, I have two pairs. I have one pair of 2's. They're going to come out, so I'm going to have that this is 2 times 2, which makes x equal to 4. Okay, so kind of replacing our variables with another variable because it wasn't set up particularly like what this was up here makes it a little easier to solve for our variable. So we found out that our x is equal to 4, and that's what we needed here. Okay, let's turn this over, and we're looking at example number 2. We want to know what is the value of x. And again, we're dealing with the 45, 45, 90 triangle. And I'll zoom in a little, okay? So this is a 45, 45, 90-degree triangle. And so we know that our legs are going to be congruent, and this is equal to 6. Well, remember on the 45, 45, 90-degree triangle that my hypotenuse is equal to x times the square root of 2. So I'm going to say that this 6 is equal to x times the square root of 2. And this is going to help me find this x over here. So 6 is equal to x times the square root of 2. And I need to solve for x. So I need to divide each side by the square root of 2. So this cancels, and so I'm left with 6 times the square divided by the square root of 2 is equal to x. Now in math, we don't like having a radical in the denominator, so what we need to do is to multiply this whole thing by 1. Well, what our 1 looks like is basically 1 is going to be equal to, in this case, the square root of 2 divided by the square root of 2, okay? This helps, sorry, move this over. This helps get rid of the square root of 2 in the denominator. So, coming over here, I'm going to multiply each side by 1. Well, this side by 1. So I'm going to have 1 times 6 over the square root of 2 is equal to x. This 1 is basically saying I have the square root of 2 divided by the square root of 2 because we do not like having a square root in the denominator. It's equal to x. So what happens is, remember, these two square root of 2's, we multiply them together, and basically the square root goes away, okay? So you have this scenario, 6 times the square root of 2 divided by, you're going to have 2 times 2 under the square root. So since I have 2 of the same thing, this is equal to x, I'm going to have this go over here. Okay. This is going to end up being 6 times the square root of 2 over 2, which is equal to x. Now 2 goes into 6 3 times. So our answer is going to be 3 square root of 2 is equal to x. All right. Now this 1, we multiply by 1 when we're trying to get rid of the radical in the denominator because we do not like to have a radical in the denominator. Okay, so here are the steps. And if you need to take a look at this, come back and review the video so that you can see how it's done. All right. All right, let's look at the next one, and I'm going to zoom out. In this example, we have a high school softball diamond, and it's a square. The distance from base to base is 60 feet, which it's showing. To the nearest foot, how far does the catcher throw the ball from home plate to second base? So I'm going to say that this is home plate. And if it's shaped like a square, we know that all these are right angles. Okay, we have these right angles. All right, so if I say this is home plate to second base, I'm going to be looking at this triangle here. Okay, this is the triangle I'm looking at. So from here to here, this bisects the angle. So what we're going to end up with is this is going to be, just want to make sure, this is 45 degrees, and so is this. This is 45 degrees. You know, these angles are congruent, okay? So what happens, and I'll zoom in a little, is I need to find this distance here. And this is a 45, 45, 90 degree triangle that I'm looking at. So my distance I'm going to use is going to be, since I'm 45, 45, 90 degree triangle, this is going to be equal to x times the square root of 2, based on what we did for 45, 45, 90 degree triangles. The 60 feet is going to be my x, okay? And we're going to use these to figure out what this distance is going to be, okay? So if x is equal to 60 feet, and my d is equal to x times the square root of 2, I'm going to see if I can figure out what my d is going to be equal to. So I'm going to substitute what I know x to be. So d is equal to 60 times the square root of 2. And we just need to multiply these two together, and we're going to round it to the nearest foot. So 60 times the square root of 2, I believe we get like 84.78 if you put in the calculator. Well, the nearest foot is 85, so this d is going to be equal to 85 feet, okay? All right, let us move to the next example. All right, example 4. We're getting to the finish line. Let's zoom out a little. So example 4, we want to know what is the value of d in simplest radical form, okay? So now we have 30, 60, 90 triangle. So with our 30, 60, 90, remember we have a short leg. I'll just write up here, this is 30, 60, 90 degree. D is going to be my short leg. 5 is going to be my long. And of course, this piece is my hypotenuse. Now for the 30, 60, 90, if you guys recall, for my short, I used x. For my long, I used x times the square root of 3. So we're going to implement that information. So for my short, x is going to be equal to d. And for my long, 5 is going to be equal to x times the square root of 3. And we're going to determine what d is going to be equal to, okay? So I have 5 is equal to x times the square root of 3. And I'm going to solve for x. So I'm going to divide each side by 3, as well as the square root of 3. And remember, so I end up with 5 over the square root of 3 is equal to x. Remember, we don't like having a radical in the denominator, so we need to multiply this side by 1. And remember, my 1 is equal to the square root of 3, in this case, over the square root of 3. Okay, this helps get rid of the radical. So I'm going to multiply this by 1, and I'm going to just show it on this one. Okay, and that 1 is basically the square root of 3 over the square root of 3 times 5 divided by the square root of 3 is equal to x. Well, this is just saying I have 5 times the square root of 3 divided by, underneath that radical is just going to be 3 times 3. Since I have one set of 3's, the 3's are going to come out. So I'm going to be left with 5 over the square root of 3 divided by 3, which is equal to x. I cannot simplify it any further. And here, let me zoom in a little. I cannot simplify this any further. So this is what my x is going to be equal to, which is also equal to my d, all right? Okay. All right, example 5, zoom out. For this example, an artisan makes pendants in the shape of an equilateral triangle. The height of each pendant is 18 millimeters. What is the length of each side of the pendant to the nearest tenth of a millimeter, okay? So we have a pendant, and so from here on down is 18 millimeters, and this is an equilateral triangle, okay? So since it is an equilateral triangle, this is 60 degrees. So each angle is 60 degrees. So if this bisects this angle right here is 30, as well as this is 30, okay? They're congruent, okay? And I'll zoom in a little, all right? They're congruent. So I am going to be looking at this piece over here, this triangle, and I am going to be concerned about this distance here, okay? So this is my short leg. I'm just gonna say it's the short. And we know the short leg on a 30, 60, 90 is x. This piece of my pendant is my long, which is equal to x times the square root of 3. And so each one of these is s. So I know that this length here is also s. They're all s, all right? But we're looking at this piece of the triangle. So this is my hypotenuse. So my hypotenuse on a 30, 60, 90 triangle is always twice the short leg. So this is equal to 2 times x. And let me move that over. I apologize, okay? So based on what we have here, we are going to determine what is the length of each side of the pendant to the nearest. We're going to find out what this s is, okay? So I know that the long leg is 18, and it's equal to x times the square root of 3. So let's write that in over here. 18 is equal to x times the square root of 3. And let's zoom out some. There you go, sorry. Now we're going to solve for x. Divide each side by square root of 3. I'm going to end up with 18 over the square root of 3 is equal to x because they cancel. Remember, we don't like to have a radical in the denominator, so we're going to multiply each side by 1. Okay, remember that 1 is equal to, in this case, it's going to be the square root of 3 over the square root of 3. Okay, so replacing that 1 with the square root of 3 over the square root of 3 times 18 over the square root of 3 is equal to x. Okay, so this is ending up to be 18 times the square root of 3 all over the square root of 3 times 3 is equal to x. Since I have one set of 3's, this is ending up to be 18 times the square root of 3 over 3 is equal to x. 3 goes in 18, we're going to end up with 6. So this is equal to 6 times the square root of 3, which is equal to x. So now, we need to find out what s is equal to. So we know what x is. And so we said s is equal to 2 times x. So my s, which is my hypotenuse here, is equal to 2 times x. Well, 2 times my x is 6 times the square root of 3. S is equal to 12 times the square root of 3. And it says that we're going to show this to the nearest tenth. So I can't leave it in the simplest radical form. So I have to put it in the calculator, and I'm going to end up with this being 20.8 millimeters. Okay? All right, those are your notes. You guys have a good one.